security. I hope we're doing well on time. Thank you. Can you?
Okay, Tony and the team, thank you so very much for honoring me. I'm here with you, and I'll be kicked. Can we go to the next slide, please? So looking at the network operations, we'll be looking at analysis of network architecture, network resilience plans, standard configuration, local access controls, and identifying bottlenecks and unwanted configurations. Then we also do a quick review of capacity assessment. So as an auditor, when starting an audit engagement of network infrastructure, the first thing I'll be interested in touching base with is the network infrastructure diagram. I think the two earlier speakers have touched base on this. It's a logical representation of the infrastructure. I'd like to explain it in a more practical way. So I'm giving an example of an individual who wants to build their house. So before the first brick is laid as the foundation, you'll be interested in having your floor plan and probably your architectural drawing. So what does these things tell us? It tells us how the rooms will be dimensioned, where your entry point comes in, where your dining is, where the master bedrooms is, and co. So in this vein also, the network infrastructure diagram tells us how our organization is dimensioned, how it is partitioned, how it is segmented. It gives us the blueprint or overview of the entire infrastructure. We've been hearing segmentation. Why do we need to segment? What is the purpose of segmenting? So I'll go back to the initial example of a floor plan. I have a building. I would definitely not expect a visitor to access my master bedroom. It's a private area for me and my family. While the guests can access the guest toilet and probably the guest room, my children's room is a no-no. My master bedroom is a no-no. My kitchen might even be a no-no. So also is the organization. Within the organization, we have sensitive functions and departments. Some are based on our policy, which is the control environment Tony earlier mentioned. Some are based on regulations. For example, a Swift pricing environment, a PCI DSS environment. There are some rules expected that based on this type of transaction or this type of process, some level of segmentation in terms of need to know should be in place. So as an organization, looking at the structure, for example, will I expect an individual coming into my organization and accessing my data center straight off, or probably going straight to my MD's office? These are locations that are restrictive. So from my network infrastructure diagram, it gives me a high-level feel of how my organization is segmented. And also, segmentation is a function of control. If I'm segmenting, a box to segment is not enough. It is the controls in place that actually define how the environment is segmented, which speaks to confidentiality of our network. It tells me who accesses what. So as an auditor, I will have expect you to understand the operational stuff of the organization, the structure we have, the departments we have, the sensitive areas we have. How are they segmented? With what are they segmented? Is it firewall? Is it switch? Is it physical access security? You need to understand this. And our infrastructure diagram shows us this. Another thing we'll also be on the lookout for at the level of redundancy we have as an organization. We'll be having redundancy, resiliency, disaster recovery. From the high level, the infrastructure diagram tells me the type of redundancy and resilience I have. For example, I have a core service to my vendor. How many links am I having with them? Is it just a single link, which we all know gives a single point of failure? If that link goes down, what happens to my service? So as an auditor, those are the things you'll be interested in. How many links am I having to my service provider based on the level of criticality? Availability is very key in network. Are my services available? How am I sure if a link goes down, there is a backup link to cater for that link? That is a level of resilience. We also look at it from the point of the devices itself. I have a core device or a core network device that links me to my service provider or through which my customers access me. If that device goes down, do I have a backup device for it? are the backup device and the primary device on the same level of configuration and patching? Because at times, one of the things we also be on the lookout for as an auditor is whereby you have the primary device, which is the core device, being patched as appropriate, top-notch, but the backup device is not at the same level as that of the primary device. So as an auditor, you'll be interested in seeing that both the primary and the backup device are at par. Again, another thing we'll also be interested in seeing is at the exit and entry points. So from an infrastructure diagram point of view, you see all sources of data entry to your organization and see all sorts of data exit from your organization. Why do we need this? How do I know when a rogue device is in? Tony mentioned something of asset inventory earlier. You can't protect what you don't know. I have my asset inventory. I should be able to see where these assets are domiciled. Where are they placed? How are they protected? What is their function within the organization? While the infrastructure diagram is a high-level document, you might not be able to see every nitty-gritty of the infrastructure, but the core devices, I must be able to see where and how they are placed and what function are they serving. And that speaks to integrity. How am I sure I'm only permitting only the required access or the required traffic from the required source? I'll give an example. There is a case that I believe we are all aware of. That's the Project Prism by the US spy. I believe we are all aware of Edward Snowden, the whistleblower in US. What happened with this project? The US NSA were able to infiltrate network of core service providers in the US, which includes Google and Facebook. And they were able to gather as much information as possible for every individual in the world, because the bulk of traffic flows through these US companies. And being them able to infiltrate this network, they were able to gather as much information as possible. So as an auditor, how am I sure the sources to my network, the traffics I'm bringing into my network are only from authorized party? Even if they are authorized, looking at the principle of least privileged access or need to know basis, how am I sure these authorized people are only accessing the things they are meant to access? They don't have excessive privileges. So these are things we'll be able to depict from the architecture on a high level before we even drill down to nitty-gritties of how these devices are configured. If there's no backup link, I'll be seeing it right away without even asking for SLA, without asking for policies. I'm seeing right away from my diagram. If my core devices are not having redundancies, I'm seeing it right away. If I'm seeing sources from my looking at traffic coming from my ISP, and I'm seeing a node that seems strange, it's a pointer. Who owns this? Do I have an agreement with them? What are they doing? What service are they providing? So it speaks volume. And the more we have the robustness of this aids our work. Most of the time, the audit client gives us the wish-wash infrastructure diagram. It's a point of concern for auditors. We should flag this. That diagram must be as detailed as possible because it's a blueprint and is the first touch point for an audit engagement. So because of time, I'll quickly move to the next slide, which speaks to baseline and baselining. Tony spoke of control environment earlier, where we have policies that are the guidelines for every organization. In networking, we have what we call baselining. Baselining can come in two folds. Can come in the form of we having a baseline configuration or network configuration admin standard for each of our organization that tells you for this type of device, this particular service should be enabled, this should be disabled. That is one part of it. Another part of it is we having a running configuration that is tailor-made towards the expectation of our organization. How do I mean tailor-made? Something like an image whereby every necessary things that should be enabled or disabled are already set. I just slam it on my switch and probably I'm changing the IPs and other minor things. But the major services or protocols or configuration that I expect to have on every of my network devices are already defined. And how does this help us? One, it helps us to identify outliners. When there are deviations, it's always easy to see when you have a baseline of what we are checking with. For example, in my organization, I expect every staff come into the organization to knot his tie, hang his badge, and probably display another form of identity. So I'm now seeing an individual coming into the organization without a badge. Anybody can easily identify that person as an outliner because the badge is not displayed. I can easily approach him that, guy, where is your badge? Are you a staff? What are you looking for? So such is a function of a baseline. It helps us to easily identify an outliner, and it also helps us in monitoring traffic pattern. Once there is a deviation from what we expect, it becomes an outliner, it becomes easier to see. And that's why an organization must have a baseline development, be it in form of documentation or you having it as your configuration file that is a template to be adopted for every deployment. So it's very key. So the next thing I'll also quickly touch point with is how do we identify bottlenecks and unwanted configuration in our configuration files. We all know for every network device, what we always reference to is a configuration file, or we call it config file. So what is a configuration file? It's a file that gives us every configuration, parameter settings, and what have you that we have on the device. That is like the brain of the device. It tells the device how to route traffic, how to block, who to grant access to, and what have you. And that is a source of truth. If someone is telling me this is done, what I'll just tell you is give me the running config of this particular device. So as an auditor, we should have that level of skill to identify what is expected to be configured based on our configuration standard and baselining. And also, we also reference security best practices. These are indications of how we should also configure our devices. While it is of best practice that controls are specific to an organization. Also, these standards helps us to tailor these controls to our specific needs. So in terms of configuration devices, we always advise that we use tools to do a scanning or review. But at times, depending on the size of the organization, tools might not be possible. We can still do a manual review. So what this slide is just showing us is it's in twofold. We are doing a manual check, and probably we are using a tool to scan, and we are comparing the two results. So looking at the first one by my right, we'll be seeing things like enable secrets, username, privileges, password. Remember in auditing what we call repudiation and non-repudiation. Repudiation is when an activity consummated by an individual can easily be denied. And as an auditor, we expect that activities should be non-repudiated, whereby if Ganil consummated an activity, Ganil should be held liable, and Ganil should not be able to deny that he actually consummated that activity. And that is tied to user identity and user profiling. Every organization has a policy as how users should be profiled. As an auditor, I'll be wary of users that are created on the network devices, generic profile. So if I'm now seeing an activity consummated by Cisco Access or Success with 55, how do I know who Success is? How do I know who Cisco Access is? Looking at the name alone, it already shows me this is likely to be a shared profile. And we all know the risk of having shared profile. Non-repudiation, Monsuru and Ife are all using Success 5. And a fraudulent activity is consummated with Success 5. Who do we hold liable for it? How do we know who did that transaction or activity? So from the username alone, you must be able to identify each and every user profiled on your devices. Ownership must be established. Justification for having them must be established. And with that, we are home and dry. Then the next one is privilege. Just like we have admin, read-only, and so. On Cisco device, we have privileges from privilege 0 to 15, and 15 is the admin. Who is having that admin privilege? Was it approved? Do we have business case for it? All these things we must be able to review and have a basis for it. If it is not approved or there is no business need, it needs to be flagged and probably remediated as appropriate. The next one is around password security, password complexity. how do we set passwords? How do we encrypt passwords? By default, password on SQL devices are set in clear text. So as an auditor, you must be sure that your password is not displayed, and that also speaks to confidentiality. Because anybody who can do the, please, can you go back to the previous slide? I'll still get here. Previous slide. So it speaks to confidentiality. How am I? Which means every password must be encrypted, in short, and not just encrypted. The strength of the encryption speaks volume. So we'll speak to that more in the next slide. And also another area we'll be interested in looking at is my line VTY and line console channels on the network devices. What do these things do? These are the channels or access through which an individual can access a network device, be it via direct line console cable, be it VTY or SSA channels and co. And this requires username and password. What password are we adding? What is the strength of the password we are adding? And who are the custodian of these passwords? You can see from the screen, from the scanning tools, there are some things that are already flagged by this. We'll be saying things like telnet being available to do a remote logon to a switch. What is the risk of using telnet? Telnet saves and passes username and password in plain text. Anybody sniping the network can always pick these users and password. And once they have these user and passwords, automatically it gives them a room to remotely access that device if appropriate ACLs are not configured. We'll be saying things like users with weak password. We all know the concept of password complexity. The more complex the passwords are, the more difficult they are to be hacked or to be broken. We'll be saying things like using type 5 type 5 password encryption. These are weak encryptions that can easily be broken within a jiffy, which the next slides will be showing us. We'll be saying things like administrative ACL, administrative line not having ACL. What is ACL? ACL is an access control list. And what does it do? It's a list that gives permission to who can access what in a particular segment of the organization. So it's like me having a beautiful and expensive house and having a gate that is so mighty. And at the end of the day, the gate was not locked. And the question will be, why do I have the gate in the first instance when it is not locked? The gate is to filter who comes in and who goes out. And that is what access control list also does. So with that access control list, we are leaving our channels open for someone to do a remote login and do what have you. So with, even if a password is compromised, with ACL, we have what we call defense in depth. A password has been compromised if that unauthorized access user is not profiled or is not granted permission on an ACL to access the management interface. So there is no way the user can actually access it, despite that profile has been compromised. So we call it defense in depth. So looking at the next slide, we mentioned of password 7 earlier. Password 7 is a very weak encryption which can easily be broken, and it's even readily available online in the public domain. Once you have the password hash or the encrypted value, all you just need is Google, place it, and within 1-2 minutes, the password will be decrypted. So the level at which, or the speed or pace at which a password is decrypted is a function of the type of password encryption mechanism that is being deployed. And you can see this password that we were able to pick the hash from the running config, and we can easily decrypt it. And we see what it is. Tonga 8ULL, which we all know, looking at the concept of password complexity, this does not meet the requirement. And this was even broken under 30 seconds. So we need to use strong encryption. And as an auditor, aside from looking at the users, identifying their identity, having a justification for you having them, reviewing the appropriate roles, you must also be sure that the password enforced is in line with the password standard of the organization. Still speaking to the control environment, that's our policy, must have been defined. The minimum requirement of our password should be configured. So the next area, the next slide I'll be going to speaks to what we also need to review as an auditor. These are unwanted services. By default, network devices comes with so many services that are enabled by default, and our standard or our baseline must tell us what is expected of each of those services. Best security standard will tell you that all these unused services should be switched off, except there is a business contingency or business need to turn them on. And why do we need to turn them off? This gives us unnecessary exposure. I believe in 2018, we are all aware of the popular WannaCry outbreak, where several organizations and multinationals were exploited, their records encrypted, and they need to pay they need to pay with their hard-earned money. So what does it on? It was a function of SMB version 1 that is always enabled by default on the OS, and that was what the vulnerability exploited. Looking at network devices, we have so many of such that can be exploited. One of it is the ICMP ping. We are all aware now. A device is down, IT will tell you, ping that device if it is up, and you ping, it replies. Fine, it has its pro. It is used for troubleshooting. But looking at security, it can be used for reconnaissance attack, where someone from outside the organization, from the internet, was able to ping to the organization. It replies from that IP. I drew a trace route. With trace route, it shows me up. Up are switches in between your destination and your source. From there, I have an idea of the IPs of switches and routers in your entire up organization. From there, I can construct your infrastructure diagram and see where and how to attack you guys. So all those things are necessary. Any unnecessary service, we should take them off. So going back to our network configuration files, what are the things we'll be interested in seeing? When you do your show running config, it gives you the details of what is configured on your network device. And the first thing you'll be interested in seeing is the version of the iOS running on your network device. Version is like the operating system. The iOS version is similar to Windows operating system or some operating system running on your switch. And the first thing you'll be interested in seeing is the version of that operating system. You know, Tony spoke around looking at Cisco device as an example. We having a SmartNet license with Cisco. It shows that the device is being supported, patches and updates and upgrades are available for you to push on your device. So in the advent of you not having a SmartNet license, you can't upgrade and you can't patch your iOS. So once you see this iOS version, the next thing you do is touch base with your OEM site and see how current or how vulnerable this version running on your operating system is. Then it becomes an exception if it's obsolete, if it is not part of what have you. So as an auditor, we need to take note of the version running. The next thing we always see is the password encryption. By default, is always disabled. And what this tells us is anything password, there is every likelihood that it is saved in plain text. And I've spoken much on that as regards confidentiality. So we need
Sorry, Ganiyu, okay. We are running out of time.
Okay, I'll just double up. The next thing is looking at the access list. Permit any is a no-no. It's similar to you having a gate without a lock. Access list should be explicit. And aside from what you are permitting, every other thing should be denied. Then the next thing is looking at your firewall. You'll be looking at what granularity of permission are you having. And looking at this last snippet, you'll be seeing things like equal to HTTP. So I'm having a core infrastructure or a core service that is permitting network traffic from an HTTP service. And we all know the HTTP, it's unencrypted, it can be sniffed, and password and information can be gained from that perspective. And this slide shows you how this looks like from the GUI of a reviewing platform, something like Skybox, something like SolarWind and Co. It shows us, it gives us a better view of how to review network rules and configuration. We can see the tuples, things that are denied or allowed. Then with this, as an auditor, all denied, especially allowed, we don't have we don't have risk, we deny rules. But for the allow rules, there must be business need and justification for every traffic, especially traffic coming from outside of the organization. So we should pay attention to all these rules, and once these rules are secured, we believe we have a better organization. So look, based on time constraint, that is where I'll be stopping for now. So I'll be introducing the next speaker, Ife Ogubambi, and you quickly run us through auditing the infrastructure part of network. Thank you very much.
So
okay.
Good morning.
Okay.
Good morning.
If I hold on a bit, guys, we are not likely. We still have a couple of slides, and it's important that we do a demonstration of how to analyze a network config with one of the tools that we'll be sharing that we have, which is NIPA. It would be nice to do that demonstration. Extra 10 minutes to the 1 hour. Is that fine? If that's fine, can you just drop type a number 1 on the chat box? If it's okay that we extend this by, say, 15 minutes max, please. We don't want to have to rush us through this. Okay, fine. All right, Ife, please go ahead. Hello, Ife, can you go ahead? Can you hear me?
Okay, yeah, sure, Tony. Good morning. So good morning, everyone. And thank you, Gani, for the last presentation. So I'll try and be fast with my own bit. So aside from looking at the configurations, looking at your architecture, as there's a bit as that we shouldn't also forget, which is the physical aspect, as in the infrastructural aspect of our network. So for this year now, as what we want to look at is your network infrastructure itself, your fiber cables, as in your shelter, your towers, and then other related components. As in you should carry out, as when you're conducting a network audit, you should endeavor to carry out a physical site survey. So for the physical site survey now, you want to be looking at things like physical security. As in the place where I keep all my network components, all my network devices, all my servers. What is the physical security like within that environment? What is access control like? Do we have surveillance around that area? And then aside from all this, you need to test all these controls also. Another thing again that we should be looking at is what has been planned. So as what is documented on your network diagram against what is actually available on the ground. We need to be able to check this. And then physical assessment of your network devices, like your routers, your switches, your firewalls. You want to check all the ports to see, okay, do we have rogue modems that are connected to our routers? Do we have as in the security of where we keep these devices? Is it okay? Another bit again is also the environmentals of the area as where we keep our network the devices and the components. So for the environmentals now, as we are going to be looking at HVAC, that's the humidity controls, humidity, ventilation, as in our ACs, as in to make sure that these are in place, and then also that we have monitoring, as that we have devices that are put in place as to monitor this, so that if there's anything wrong with our HVAC system, as the guys who are managing that data center are alerted. So as I'm going forward, as a part of the reason why we want you to look at the physical areas of our network is an example, as on our screen now, as we have an example, bad cabling. Bad cabling can cause a lot of downtime, a lot of issues around availability. So we should endeavor that whenever we are carrying out our network audit, we should visit our data centers as part of this, so as we should put it in scope. As you'll be shocked as what major data centers as we have around, as that have issues around bad cabling. So and then also going forward now, another bit again as that we should also look at. So as we have looked at governance, as we have looked at operations, another bit also is network security. Network security, it sets as the auditing network security is for us to determine the adequacy and then the effectiveness of network security controls in to understand how well our organizations are protected against security threats, whether they are coming from the inside or coming from the outside. So as in, there are two parts as in that we should look at here. Number one is the static data. So here now, as in, we should be looking at the protocols as in that are being used, our system definitions, our password rules, firewall definitions. Gani has spoken about this, so I wouldn't dwell on it. And then the second part also is to look at as in our data security softwares, as a modification to files, transfer of files, access to our critical as a network infrastructure. Next slide. So there are major tools or major components as in that help us to ensure security of our network. We have the firewall, we have network access control, we have IPS and IDS, which is intrusion detection system and intrusion prevention systems. We have our VPN and our wireless network. So but for time, as we are just going to deal with the firewall, Gani has spoken a lot about the firewall, so as I won't dwell on it. However, if you are going to be auditing the firewall, you should be looking at your firewall security policy. As in, the firewall security policy can be embedded in your overall information security policy or maybe your network policy. You should be looking at the as in the SOPs, that's the standard operating procedures, as in that deals around how you manage manage your firewall. You should be looking at user access control, which is the administrators, as in who has access, as what kind of access do they have. You should be looking at your firewall change procedures. This is important. So for any changes that occurs on your firewall, it should be documented, it should be approved. So there should be a procedure in place, and then as an auditor, these are the bits as in that you should be looking at. Another bit again as in that we should look at is a NAC. So firewall presents as in protects both as that's external access. That's people who are trying to come into your network as either from the internet or even internally. However, for the NAC, as a NAC is focused on your physical access to your network. It protects physical access to your network. So as auditors, when we are carrying out our network audits, we should also look at the NAC. So what is our configuration of as on the NAC? As what rules have been set up as for us to admit people as in admit devices on our network? As in, are those rules actually adequate? As in, are they valid? As are they being monitored and refreshed regularly? And then finally, the last bit that I want to talk about has to do with as kind of like a checklist when we want to audit our network devices. I know as in each of the previous speakers have spoken to this in one way or the other, but as in I will just highlight them. Number one is, for your network devices, you should ensure that it is running the latest stable operating system, and that our patch levels are up to date. This is very, very important. This is one of the easiest way of attackers gaining unauthorized access to networks, because when you have network devices that are out there that are already obsolete, it's and then that are vulnerable to known vulnerabilities. It makes it very easy for an attacker. The next one too has to do with authentication. So for authentication now, you should ensure that that you're using an authentication server, either Active Directory or Radius. And then also on the local devices, you should limit the number of local users that you have on those local devices. Ideally, it is recommended that you should have only one as a backup in case if your authentication servers are down. Thirdly, you should verify as that the organization has implemented account management processes for user access. This is very important. So the account management process is where we define things like as auditors, this is where we are checking to see, okay, who actually has administrative access. Are they still valid members of our organization? As we are checking for password complexity, Gani has spoken about this extensively. As we are checking for privilege. That means the privileges that are assigned to users, are they limited to just what they want? The next bit is to validate as in that your network devices are synchronized with your organization's time server. This is very important because as when logs are generated, it makes it easy as for you to be able to correlate events. So as when logs are generated, they should have the ideal as in the exact time, as in that is the same as with the organization's authoritative time server. Privileged accounts are also reviewed periodically. You should ensure this, as in that the privileged accounts are being reviewed periodically, at least semi-annually. You should ensure that changes and updates are documented, ensure that login is enabled, and then as that this login, it is ideally being moved as onto an external login server, and then as in that server has the capacity to retain logs as in for the required retention period. So for firewalls, you should prohibit protocols as that are not explicitly defined. So you should not just do as in this is where the any comes in now, as when you're defining access control list and then you're saying any. No, as in we shouldn't have that. It should be from a specific protocol or a specific service, and then it's going to a specific destination. You should ensure that your firewall restricts traffic. Okay, then finally, as when we are carrying out audits, we can carry out security audits or network audits using two means, which is either manual or using automated tools. Using manual means works. However, how effective is it? When you have an organization that is very large, as in that has devices, example now firewalls, as in with over 1,000 rules, how can you manually review those rules? As in there's a cost as into that. As in the cost being that if you miss anything, as if you miss a rule that is too permissive, as you are exposing your network. So that is why it is advisable, as we advise that you should use automated tools. Example of the automated tools that are out there in the market, and then we have used this example is Skybox. Skybox is a security suite of software that integrates data from firewalls and the network devices, as with vulnerability and threats as an intelligence. We have Toffins, we have SolarWinds. As a SolarWind can be used for performance monitoring. It can be used for configuration change monitoring. We have Napier